All right, guys, so we're going to talk about a unit vector today and what exactly that is and how to use it and all of that fun stuff. So basically what the unit vector is it's any vector that has a magnitude of exactly 1. So that's what we're going to put here. It's a vector with a magnitude of 1. And by that, I mean exactly 1. Let's remember that magnitude is talking about the length of the vector from start to finish. So if you kind of compare that to some of the stuff that you've already done this year, we did unit circle. And remember, the unit circle was a circle with a radius of 1. Therefore, it was called the unit circle. Same thing here, that it's called a unit vector because it has a magnitude of exactly 1. And then, so what you have from there, what your standard unit vectors are, is that you have your horizontal, which we've already talked about component form of vectors, where you have the horizontal component and you also have the vertical component. And so what we have for those, for both the horizontal unit vector, you're going to signify that it is the horizontal unit vector with something having an I hat. So it's not got the little dot on top of the I, it's just got the I and that little arrow up. And the vertical one is a J hat. Okay, so it's wearing a little hat on it. And that's how you're going to signify that it is either horizontal or vertical. I always remember those just because they're alphabetical. I comes before J in the alphabet, just like X comes before Y, and we all understand that X is our horizontal and Y is our vertical. Okay, now, any vector can be represented as the sum of unit vectors. So for example, what we have right here, this is saying that it wants me to do vector AB as the sum of unit vectors, where we've got the coordinate point A, which is 4, -1, and the coordinate point B, which is 6, 2. So first, let's go ahead and plot those points and figure out what we've got going on there. So I have this coordinate plane over here. It's not labeled or anything for me, so I'm just going to go ahead and go, okay, I've got to go at least 6 to the right, and I've got to go 1 down and at least 4 up, or I'm sorry, 2 up. So I'm going to go ahead and go 1, 2, 3, 4, 5, 6, 7. Okay, I can fit 7 there. And then I'm going to go ahead and go, okay, I've got 1, 2, 3, 4, and 1, 2. I'm just doing this just to kind of help make sure that I have enough space on my x-axis and my y-axis to plot my points. So now I've got A, it's at 4, -1, so I'm going to do 4, -1 right here. Here's A. And then I've got B at 6, 2, so that's going to be at 6, 2 right here, and here's B. So my vector connects the two of these. Okay. My vector connects the two of those from A to B, and I'm doing the arrow is going to be because again I've got this AB right here, and if you notice up top here I've got that little line and it's got that little spot sticking out to the side there. That's kind of showing me that I'm going from A to B. I could also have it going from B to A and had that little line kind of going like that. If it was doing that B to A, that would tell me that it was going from B down to A. Okay, just kind of a little side note to make. So now what I've got right here is I've got to figure out how many times have I moved horizontally and vertically and in which direction. So for example, to go from A to B, I go 1, 2. I go 2 units to the right. So since I'm going right, it's positive, and this is going to get me 2i, because I've gone 2 individual vectors with a magnitude of 1 to the right. And then from here, I'm going to go 1, 2, 3. I'm going 3 vectors, or 3 units up. And so I would go plus 3j. Okay, that's how you're going to represent it as a sum of unit vectors. We already would have taken this previously and gotten component form of this going, oh, okay, so we go right 2 and up 3. We would have written this as component form of 2, 3. This is exactly the same thing. It's taking your component form, and instead of writing it like that, you just write 2i plus 3j. If it was -3, then it would be 2i minus 3j. That's how you're going to do that as a sum of unit vectors. Because remember, sum means addition. So that's what we're doing, is we're just adding up our horizontal and our vertical vectors to get us what our component form would be. So then let's look at this next one. It says, find the magnitude of each vector, then write each vector as the sum of unit vectors. So first thing that I have to do is I need to go ahead and find the magnitude, because remember, you have to read the directions and do all parts of the directions. So first I'm going to find the magnitude. So in order to find my magnitude, remember that's the square root of a squared plus b squared. And this is your a, and this is your b. So I'm going to go ahead and go, I've got 8 squared plus -6 squared. So that's going to get me the square root of 64 plus 36. When I add those up together, I end up getting the square root of 100, which is 10. So there's my magnitude. Magnitude. Okay. And I'll even mark that note here. Magnitude. Okay. Then we're going to go ahead and write this as a sum of unit vectors. So all I do is I take that horizontal component form, and it's written as 8. So I'm going to turn this into 8i. This is -6, which tells me I go left 6. And so I'm going to go minus 6j. So there is your sum of unit vectors. Okay. So this is what I got here, and this is here. Okay, hopefully that'll make some sense for you. Just in case you're still struggling with it, let's go ahead and do this next one. I encourage you to pause it, do the work, and see if you got it right. So what I'm going to do here is I do -7 squared plus -5 squared, which that's going to get me 49 plus 25. And when I do that, that's going to go ahead and get me 74, which does not reduce. 74 is not a reducible square root, so we just leave it as that. So there's my magnitude. And then I'm going to go ahead and figure out my sum of my unit vectors. So that would be -7i minus 5j. Without the hat, it's not the same. Now, if you notice down here on these questions down here, I have let u equal -3i plus 8j and v equal -2i minus j. None of these have hats. The reason that they don't have any hats on them is simply because they're bolded. If you notice right here, this u also does not have the little vector symbol on it, which we know is like that. Because you and I, when we write, we don't sit here and go, okay, I have a bolded U. You know, you can do that in type, but writing it out in actual print, it's not something that you're going to do. So you and I, we would do U like this, whereas in print, in type, you can go ahead and just bold things. Same thing for the unit vector I. Since it's an I like that, it's not just a lowercase I that's not bolded. That would indicate that it is an imaginary number. So since this is bolded, that tells us it is the unit vector. So just keep that in mind as you're proceeding through any of the assignments that you're given. All right, so what I've got right here, what we're going to go ahead and do is we're going to do u plus v. So I'm going to take u, which is -3i plus 8j, and we're going to add v, which is 2i minus j. Remember, when I don't have a coefficient, the coefficient actually is just 1. Okay, so if you need to write it, write it. If you don't feel compelled to write it, then you're perfectly fine with that. So then here, all we're going to do is we're going to combine like terms. This is addition. It is not multiplication. So that means I'm not going -3 times 2. I'm just combining like terms. So I'm taking negative 3 and I'm adding 2 to it. When I do negative 3 plus 2, I get negative I. When I take 8j and I add negative 1 to that, that's just going to get me 7j. Okay? So this is all I'm expected to have for my answer if I'm finding the unit vector given this. Let's try this. Should be nice and easy. So let's go. 2u. So u is negative 3i 8j. So I'm going to go, I've got 2 times negative 3i plus 8j. And then I'm going to subtract 3 from 2i minus j. Okay? So, order of operations matters. I have to multiply before I add and subtract. So first thing I'm going to do is I'm going to go ahead and distribute my scalar multiple to what I have for my vector right here. This is saying that I have this vector 2 times, so I have negative 6i plus 16j. And I'm going to go ahead and distribute this negative 3. And I'm going to turn this into addition. So this is negative 3 times 2, so that's negative 6i. And this negative 3 minus j becomes plus 3j. Okay, so notice I wrote the second part in parentheses. The reason I did that is because I turned it into addition. I'm just doing that because I multiplied everything by negative 3. If I did not multiply by negative 3 and instead multiply by 3, then I still would have a subtraction sign to distribute. Okay, but since I've distributed everything and I've turned it into addition, I don't even have to worry about these parentheses anymore. They could just disappear just like that. So now instead all I do is combine like terms just like before. So I have negative 6i and another negative 6i. So this just becomes negative 12i. And then I've got 16j plus 3j. And so then that's going to now become 19j. And that right there is written as a sum of unit vectors, saying that I have negative 12 horizontal vectors and I have positive 19 vertical vectors, all with a magnitude of 1. That is going to get me what 2u minus 3v is. It should be pretty straightforward. Let me know if you have any questions while doing your work.